questions on multiplication table. So basically, we're asked to construct the multiplication table for the group formed by the symmetry operation. So basically, we have this structure to be this, right? So we have this is 1,3 dichlorobenzene, right? So we need to know the symmetry element here. So basically, the principal axis is this. We have it to be C2, right? So we have identity, we have C2, right? So what else again? Do we have a mirror plane? So we have a mirror plane at this point. So this is sigma V, right? There's no sigma H, right? So we also can have a mirror plane this way that cuts through everything. So this is sigma V prime. So these are symmetry elements, right? So now we need to construct a multiplication table with this symmetry element. So we have identity, we have C2, sigma V and sigma V prime. So let's construct the table. So we have this and this. So at this point we have identity, so let's put it there. We have C2, let's put it there. So we have sigma V, let's put it there. So and then we have the sigma V prime, right? So now let's look at the structure again. So the first symmetry element is identity, right? So this is a structure. We have a structure to be this, and we have this Cl. So when we carry out identity on this, we're going to have identity. So let's call this 1, chlorine 1 and chlorine 2. So we're going to have the same structure, right? Chlorine 1 and then chlorine 2, right? So let's look at B. So B is basically carrying out C2. So we have this structure. We have C1 and we have Cl2, right? So that's chlorine. So when we carry out C2 operation, so this one comes here, this one comes here. So we have this. We have this to be Cl2 and then Cl1, right? So let's see the third. So we have the mirror. So we have this to be this. This is chlorine 1 and this is chlorine 2, right? So if we carry out a mirror, so the first mirror is this, like what is here is showing here, what is here is showing here. So that's going to give us the same thing as C2. So that we're going to have Cl2, Cl1, right? So and the D, we're going to have it to be this. So we have Cl1, Cl2, right? So we have sigma V prime. So the sigma V prime is we cutting it here. So this one remains in its position. This one remains in its position. So we are going to have Cl1 and Cl2, right? So this is it. So when we carry out identity multiplied by identity, we have identity, right? So identity times this, we have C2. We have this, we have sigma V. Anything times identity, we give that same value, right? So for this side also, we're going to have C2, we're going to have sigma V and sigma V prime, right? So now let's look at multiplication of C2 and then C2. So C2, this is C2, this is a structure, right? So we have chlorine 1, we have chlorine 2. So when we carry out C2, we're going to have chlorine 1, we are going to have chlorine 2 and chlorine 1. So when we carry out C2 again, we're going to have identity, right? We're going to have chlorine 1 and then chlorine 2. So basically, C2 multiplied by C2 will give identity. Mirror multiplied by this will give identity, and this multiplied by this will give identity, right? So now let's look at this multiplied by this. So sigma v is this, right? We have C2 and then Cl1, chlorine 1. So when we now multiply it with C2, so C2 will cause this to change. This will come A and this will come A. So we are going to have Cl1A. So we are going to have Cl1A and Cl2A, right? So that's more or less like sigma v prime, right? So multiplication of this, multiplication of this and this will give sigma v prime, right? Will give sigma v prime. So let's look at this also. Multiplication of sigma v prime and then C2. What would I give? Sigma v prime. This is sigma v prime. It gives Cl1, Cl2, and then we now carry out sigma v prime on it. So this is sigma v prime, right? Giving this, right? Let's look at it again. So we have sigma v prime. This is sigma v prime, right? It gives Cl1, Cl2. Now we now carry out C2 on it. So C2 will cause Cl2 to come here, Cl1 to come here. So this is similar to sigma v. So we have this to be sigma v, right? So now for C2 also, let's look at C2. We have C2A. So C2 gives Cl2, Cl1. So when we now carry out sigma v again on it, so sigma v will cause the structure to become what? Sigma v will cause the structure to have to change, right? So looking at it again, we have C2 causes it to change, and sigma v will also cause it to change. So we are going to go back to Cl1, Cl2, and that will give us sigma v prime, right? Sigma v prime. So let's look at sigma v prime and sigma v. That should give us C2, but let's look at it. Sigma v prime will give us Cl1, Cl2. So this one, sigma v, changes, sigma prime does not change. So we have this. So this one will change it to Cl2, Cl1, and that's similar to C2. So we have this to be C2. Now looking at this again, C2 changes it, right? Cl2, Cl1, but sigma v prime, let's look at sigma v prime. So sigma v prime does not change it, but sigma C2 changes it. So C2 changes to Cl2, Cl1, right here, and then sigma v prime does not change it. So we are going to have sigma v prime, sigma v rather. This is sigma v. So this one, sigma v and sigma v prime, this will give us C2. So basically the trick is this. Look at this. Once you are able to like secure the identity all through the diagonal, right? So the multiplication of any two will give the third value there. The multiplication of C2 and then let's look at it. The multiplication of C2 and sigma v will give so the multiplication of C2 and sigma v will give sigma v prime. Multiplication of sigma v and sigma v prime will give C2. So multiplication of any two will give another value that is not being multiplied. So now let's look at this. To construct the multiplication table for C3, we basically have to use the distinct symmetry operation method. So C3 becomes C3 prime becomes C3. So C32 will give us C32, and then C33 will give us C33, which is identity. So C3 is this. It's like having a isosceles, a equilateral triangle. So we have this is C1, this is C2, and this is C3. So when we carry out the first C, so this is the point there. When we carry out C3 prime, we're going to have this one turns. We are going to have C1, C2, and then C3. So let's say we carry out CL1, still the same. Let's say we carry out C32 on it. It's like carrying out C3 twice. So this one will move here, right? So we are going to have this C1, C3, and then C2. So let's call this A, let's call this B. So the C, let's look at C. So let's say we carry out C1, C2, and C3. Let's say we carry out C33, which is the same thing as identity. This will move by 1, 2, 3. So it's going to give the same structure. We're going to have C3, C1, and then C2, right? So to construct the multiplication table, we need to have identity, C3 square, and then C3. So it's going to be identity, C3 square, and then C3 on this side, and then we have on this side also identity, C3 square, and then C3. So we have this and we have this, right? So now when we carry out this gives identity, C3 square, and C3. For this side also we have C3 square and C3. Now C3 multiplied by C3, we're going to have, this is C3, C3 square multiplied by C3 square should give us C3. But let's look at it. C3 causes this to come here, to move by 1, right? So this one comes here. Okay, let's see. Oh, sorry, moves by 2 rather. So this one 1, 2. Then we have the structure. So now C3 is going to be C3 twice is going to be this. We're going to have C3, C2. So it's going to give C3 square. That will give us this. C1, C3, C2, and then C3 square again will give us identity. C1, sorry, C3 twice will give us C1 here, C2 will be at the top, and C3 will be at the top here. So this is similar to C3 square. Let's look at it again. C3 square is when we have this one moves by 2, so we have it to be here, right? So also looking at this here, C32 means this one moves 1 and 2. So we have 1 here, we have 2 here, and we have 3 here. So when it moves twice again, we have it to be 1, we have it to be 2, and we have this to be 3. So this is going to be similar to C3 prime. So we have it to be C3 prime. So this one, multiplication of this will give us the multiplication of C3 will give us C3 prime. So the multiplication of this C3, so this is C3, this is C3, right? I'm sorry, C3 prime rather. So this is C3 prime multiplied by C2. So this one will move 1, 2. So we're going to have 3, 1, and then 2. So for the multiplication of C3 prime and C3 2, we're going to have 1, 3, 2. So this is similar to C3 3. So we have C3 3. So we can drop the answer to this remaining one in the comment section, and let's see. Drop the answer to the comment section. Well, basically what we just need to do is this: C3 2 and C3 should give you C3 prime, and then last one there.